So I just want to finish up talking about flash labels to finish up this video on electrical safety and just explain the various things that are on the flash label. Nowadays, most electrical panel boards that are being installed are required to have this warning on it. The contents of the label are still quite varying and in question, but this is a label that I have used and contains all the information that I like to have on it. Now, most of this stuff already we've discussed. If we take a look at, for example, this tells me what voltage this panel is, 0.48 kV. Tells me the limited approach boundary, the restricted approach boundary. Now, this label was printed before the prohibited approach boundary was removed, and so now the minimum approach boundary for us is 1 foot, and that's what we would know as a voltage approach boundary, perhaps. Okay. The other approach boundary that we've just recently here introduced is what's called the flash boundary, and let me explain that just a little bit. So, the flash boundary, what it is, when I open up a panel and expose myself to an energized circuit part of some sort, someone has done a study and said that the flash boundary in this case is 10 inches. And what that means is if I cause a fault, and a fault is something that I've got, you know, the example I usually use is a crescent wrench. I'm using a crescent wrench to tighten some bolts or something like that that's not insulated, and I get that crescent wrench across all 3 phases and cause what's called a flash or an arc, and or an arcing fault. And what this study then reveals is that 10 inches from that point, or that circuit part, energized circuit part, I can create a second-degree burn. Which means at 10 inches, I have available 1.2 calories a square centimeter of incident energy, which can cause a second-degree burn. And as I said up above there, you can equate that to 175 degrees to 0.1 seconds. Okay, so that covers the flash boundary. The flash hazard, the next thing that we list on there is what's called the flash hazard. And they use a standard working distance of 18 inches. And what that is it tells me the incident energy at 18 inches. And in this case, it's equal to 0.6 calories a square centimeter. And all that's telling me is that I wouldn't suffer a second-degree burn at 18 inches. Probably would cause 0.6 would probably cause some skin irritation or something like that. But that's how that works. Then the last thing there is what we call the PPE level, or nowadays it's a little more commonly called the hazard HRC, hazard risk category. And that is required. And what that means is that to work on this box with an energized, my clothing has to be HRC category 0, which, by the way, is in this case it's 0 because at 18 inches there's really no risk of a second-degree burn. Now again, this is another item. 2017, this was removed. And my consulting work, I still continue to use it because I just find it to be more hazardous without having that category myself. Time will only tell whether that's a good idea or not. But let's talk about the other risk categories that are out there. If you have a PPE level or a hazard risk category that is category 1, what that means is the clothing that you're required to wear is rated up to 4 calories a square centimeter. So category 1 really means that the risk is from 1.2 calories square centimeter to 4 calories square centimeter. So anytime you get above that 1.2, you go from 0 to 1. Okay? And your clothing then has to be rated up to 4 calories so that if an incident hazard does happen, then your clothing will not catch fire and you will get burned. Hazard risk category number 2 is rated up to 8 calories a square centimeter. So when we're doing studies, the incident energy gets above 4 calories per square centimeter at 18 inches. Then we go to hazard risk category 2, which in my mind really means 4 to 8 calories square centimeter. And the next category is 3, which is 25 calories a square centimeter. And hazard risk category 4 is 40 calories. What most people do is equip their electrical personnel with category 2, but you have to keep in mind that you have to know that your incident energy, if you're in hazard risk category 2 clothing, is you have to know that the incident energy available at 18 inches is less than 8 calories. So anyway, hopefully that explains hazard risk category. And the last thing I want to talk about is that in our labs, I have a label that I made up. So here is the label that would exist on the switches in Schrank Hall South 237, where we plug our control panel boards into. And I want to point out that it's 208 3-phase coming in there. The arc flash boundary is 2 inches. And let me explain a few things. So here's my switch. In that switch, there are 3 poles. And when that switch is open, those poles would look like this. Okay? If I were to open up the front panel on that door, we would be exposed to 208 volts, what's called the line side of that switch, where our leads come into, is still energized. We haven't switched the breaker in the hallway that feeds us. We've only opened the switch. Down here, when the switch is open, we're off. If we've established an electrically safe work condition, we measure the voltage and all that good shit, all that good stuff. Okay, and so I just want you to know, in a worst case scenario in the room, if we were to open that switch. Now this does not include the cable. Now you guys have a plug and a cable that goes over to a switch on your panel board. That switch then goes to a transformer, and the incident energy continues to go down from this point. I am actually talking about this point right here. And so the incident energy continues to go down as you get over to your control panels. On the control panels, here with this transformer being 208 to 120, we're down here at the 120 volt level, which, if we measure voltage, we have to have hot gloves. We're greater than 50 volts. But I just want to tell you and reveal to you what the expected flash is in this room. And it is 2 inches at 18 inches from that switch on the wall. There's potential for 0 calories per square centimeter. And so there really is no risk of getting a burn or an electrical accident from a flash standpoint in this room. You can still get shocked, okay? But we do use finger-safe terminals and things on those panel boards to minimize that effect. And I don't ask you to measure voltage. If we ever need to measure voltage, you'll see me doing it with hot gloves and a meter. So that concludes the video on electrical safety.